All right, we're going to start with what seems like a really simple guessing game. But trust me, don't let its simplicity fool you. How you choose to play, well, it actually reveals a powerful way of thinking that you can apply to, everything from big economic theories to your own daily decisions. Ready to play?
Okay, so I want you to actually play along with me right now. Go ahead, think of any whole number between 1 and 100. Seriously, don't overthink it, just whatever pops into your head. You got it? Good. Now just hold on to that number for a moment. Now, here are the rules of the game. They're pretty straightforward. Imagine everybody watching this explainer picks a number. We take all of those numbers, find the average, and then, and this is the key part, we'd multiply that average by 2/3. The winner? It's the person whose original number is the closest to that final target. So, now that you know the rules, you want to change your number. So what's your first instinct here? Well, a pretty simple place to start is just to assume that everyone's picking numbers completely at random. If that were true, the numbers would be all spread out, and the average would land right smack in the middle, 50. Okay, so if you're assuming the average is going to be 50, and the whole point of the game is to get 2/3 of that average, then a really logical choice is 33, right? This is sort of the first layer of the puzzle. But the game is definitely not over yet.
And here's the kicker. What if everyone else watching this is just as clever as you are? I mean, if everyone assumes the average will be 50, and so they all pick 33, well, the average isn't 50 anymore, is it? Suddenly, the average is 33, and 2/3 of that is 22. So, should you pick 22? But wait, what if everyone figures that out too? You can already feel yourself going down this logical rabbit hole, can't you? It gets complicated fast.
To get out of this kind of logical loop, we can't just keep guessing what other people are going to guess. We need a much better way to think about the problem. And this is where a really cool tool from game theory comes in. It helps us identify what we might call a crazy or totally irrational choice. So let's take a quick detour to a classic example from history. You're Hannibal, you got to cross the Alps, you have an easy pass and a hard pass. The defender can only guard one of them. Now, if you take the easy pass, you do okay if it's guarded, but you do great if it's not. If you take the hard pass, you do okay if it's unguarded, but you do terribly if it's guarded. So look really closely at those options. So think about Hannibal's choices. No matter what the defender does, taking the easy pass is at least as good as, and in one case, it's way better than taking the hard pass. For Hannibal, that hard pass option is what game theorists call a weakly dominated strategy. It's basically a choice that's never your best move, and it could even be your worst. And this leads us to a really simple but super powerful rule. A rational player who is trying to win is never going to knowingly choose a dominated strategy. I mean, why would you? Why would you pick an option that's guaranteed to be either worse or at best just the same as another choice you have? You just wouldn't. And this insight right here, this is the key that lets us start getting rid of all the crazy choices. Okay, so let's bring that idea, eliminating dominated strategies, all the way back to our number game. We can use this rule to see if we can surgically remove the bad choices and find the one perfectly logical answer. Let's start from the top. What is the absolute highest the winning number could possibly be? Well, let's imagine the craziest scenario. Every single person playing picks 100. The average would be 100. And what's 2/3 of 100? It's about 67. That is the absolute ceiling. So think about that. If the target number can never be higher than 67, then picking a number like 70 or 85 or 99 is, well, it's logically pointless. It can never, ever win. These are dominated strategies. A rational player would never pick them. So, boom, we can just eliminate every single number from 68 to 100. And this is where it gets really cool. It's like a logical cascade. Just follow me here. If we all agree that picking above 67 is a bad move, then the highest the average can possibly be is now 67, right? Okay, so 2/3 of 67 is about 45, which means now any number above 45 is a dominated choice. We can get rid of those two. But hold on. If no one picks above 45, the new highest target is 2/3 of that, which is 30. And you see where this is going? This logic just keeps eating away at the numbers. It keeps going and going all the way down to 1. So, okay, the purely logical game theory perfect answer is 1. But this is the exact point where pure cold logic just slams right into the messy wall of real human behavior. A Yale professor, Ben Pollack, he actually ran this exact game with his students. What do you think happened? The perfectly rational answer, the one that the pure logic leads to, is 1. But remember, to win this game, you don't have to be the most rational person in the room. You have to predict what the average person will actually do. So you think 1 was the winning number?
No, not even close. In one of his classes, the average guess from all of the students was 13.3. Let's just look at that for a second. The perfectly logical answer was way down here at 1, but the actual class average was all the way up at 13.3. So the winning number, the one closest to 2/3 of that average, was actually 9. The person who won wasn't the most logical player. They were the best at predicting what the group would do.
So what is going on here? Well, it turns out the real game isn't about pure mathematics at all. It's about psychology. It's about trying to read the minds of all the other players. And this reveals the true objective. Your goal is not to be a perfect logician sitting alone in a vacuum. Your real goal is to be just one step, one level of sophistication ahead of the average player. If you think most people are going to do that first step of thinking, your job is to do the second step. If you thought they were all game theory geniuses, then you'd pick one, but they're not. Professor Polak, the guy who ran this experiment, he put it perfectly. He said you have to, quote, put yourself into other people's shoes and think about how sophisticated they are at playing games. It's not just about knowing the rules. It's about guessing how many steps of that logical cascade other people are actually going to follow. So you can kind of break this all down into levels of thinking. You've got level 0 players who just pick randomly. Then you have level 1 players who think about the level 0s and pick around 33. Then you have level 2 players who anticipate the level 1s, and so they pick around 22. That winning guess of 9, it suggests that the average player in that classroom was operating somewhere between level 1 and level 2. The winner wasn't the best logician, they were the best sociologist. And that right there, that's the big takeaway. In pretty much any strategic situation you find yourself in, I mean, a negotiation at work, investing in the stock market, you have to stop and ask yourself, am I just analyzing the rules of the game, or am I analyzing the people who are playing it? Because very, very often, that's where the real winning move is found.